What do you think? What results would Rutherford and his students have observed if the planned pairing model had been accurate? Note that in this model, the matter making up the atom was thought to be spread more evenly within the atom and not concentrated into a small space at the center. Niels Bohr refined the atomic model to explain how electrons were positioned around the nucleus. Rutherford's work shed light on the presence of an atomic nucleus, but it didn't reveal any new information about the positions of electrons in an atom. Niels Bohr, a student in Rutherford's lab, it goes from teacher to student, from the student becomes a teacher, and then the teacher has a student that improves their work. That's how science works, improving the models. Work on extending Rutherford's model to explain how electrons were arranged in the atom. At that time, scientists knew that different elements emitted different patterns of light when they were heated to high temperatures. They also knew that the pattern of light emitted by an element could be described by a mathematical relationship. Bohr took this idea one step further and hypothesized that the mathematical relationship indicated the presence of different energy levels for electrons within the atom. From this, Bohr developed a model of an atom with a central nucleus surrounded by electrons moving in orbits. Moving from the nucleus outward, each orbit represented higher energy than the previous one. In Bohr's model, electrons could move from one orbit to another. If an electron moved from a lower energy level to a higher one, it had to absorb energy to make the move. If an electron moved from a higher energy level to a lower one, it lost energy in the form of light. This explained the light emission spectrum of a hydrogen atom. However, scientists gradually realized that hydrogen is the only element whose light emission spectrum fits Bohr's mathematical calculations. Despite this serious flaw, the Bohr model of the atom continued to be important to scientists. The idea of specific energy levels for electrons became an important one that endured even after the model itself was found to be inadequate. Discover science. Scientists now think of electrons as occupying electron clouds, not orbits. Scientists today accept and continue to use the idea that each electron in an atom has a specific energy. They also accept the idea that electrons absorb or lose discrete quantities of energy called quanta. However, they reject Bohr's idea that electrons follow specific orbital paths around the nucleus. Instead, scientists now think that the exact location of an electron in an atom cannot be known at any given time. Instead, we can know only a range of probable locations. These locations are best described as electron clouds because they are three-dimensional spaces with fuzzy borders. Scientists use the term orbital when they refer to the location of an electron in this model.